In this video, you will learn to find the surface area of rectangular and triangular prisms. Now, as we begin, we need to review over some basic terms, and then we're going to add a couple new terms as well, and then we'll use those different terms and understanding of those terms to develop formulas to find the surface area of prisms. So to begin, let's work on different types of prisms. So our basic definition of prisms would be a prism is a three-dimensional shape that has two congruent polygons for its bases. So we have bases that are congruent, and the bases will also be parallel. Then the other faces are called are going to be parallelograms. All right, so here are some notes about prisms, and then also make sure we know that the prism is named after its base. So for example, this first prism here is a triangular prism because the bases are triangles. All right, and the other sides are parallelograms. For this next one here, this is a pentagonal prism because the bases are pentagons. So we can name it based after the base. And then this last one here is a rectangular prism because the bases are rectangles. All right, so these are different types of prisms. We have basically any number of types of prisms that we can have. We can have prisms with different bases that are maybe just a different quadrilateral, could be a hexagon or heptagon or octagon. So the bases can be any polygon, but here are just three different examples. Now with the rectangular prism, we discussed in the past some terms. So we have what's called the faces, which would be the flat surfaces. So like the rectangular part, it's like here in the top or the bottom, or like this left or right side or the front or back. Those are all faces. Then we mentioned edges. Those are the segments where two faces meet. So you have, these different segments here. So like this would be an edge right here. This would be an edge. So any line segment you see, pretty much where the faces meet, would be edges. And then the vertex would be the points where the three edges meet. So like, for example, here, this would be a vertex, this would be a vertex, vertex, vertex. So all of these would be different vertices, all those points. So we're going to expand those definitions to include a few more. So we have what's called the base of the prism. And in general, the base would be the sides that are parallel. The only thing is with the rectangular prism, all the sides are parallel, right? The left and the right are parallel. The back and the front are parallel. The top and the bottom are parallel. So for rectangular prisms only, the bases will be specified as the top and the bottom. So for other types of prisms, that will not always be the case. Okay, but for rectangulars, top and bottom. So like up here, this would be a base, and then down here would be the other base. And then the other sides that are not on the top and the bottom are called lateral faces. So we've learned the word equilateral in the past, right? And equilateral, equal means equal. Lateral has to do with the side. So an equilateral triangle would have equal side lengths. So when it says lateral face, what we're discussing is the faces that are on the side. So the side faces. So that would be like this left side over here, and this right side over here, then the back side, and then this front side right here. So those would be the lateral faces of this rectangular prism. It's the sides. Now a couple more terms with a prism. We have what's called the altitude. So the altitude is sometimes used as the same as the word height. So altitude and height are kind of the same thing. Technically speaking, is a segment that joins the two bases and are perpendicular to each other. So we said the bases would be the top and the bottom. The altitude would be a segment connecting those. So like right here in yellow, this would be one of the altitudes. Or it could be this segment right here in the front, or on the other side or in the back. Any of those segments connecting the two bases would be an altitude. And now the length of the altitude is called the height. So for most purposes, height and altitude are used interchangeably. Technically speaking, altitude is the segment, so just the shape connecting the two bases, but the height is the length of that segment. Then we have in this picture the width and the length. As you see, length is, this left to right, and the width is kind of back to front, and the height would give you that third dimension. All right, so make sure you know your terms, the parts of a rectangular prism. And for a triangular prism, it's going to be the same type of idea, where we have the bases are going to be the sides that are parallel. Now be careful though, because base, we usually think of sides that are, on the bottom of something, but with a prism, the base are the parallel sides. So with a rectangular prism, the bases were specifically top and bottom because all the sides are parallel. But here, the only two parts that are parallel are the triangles. So the triangles are going to be your two bases. So this front triangle here in the front, triangle AFE, and then the triangle in the back, BCD. Those two triangles are the bases. And then the altitude, or the height, is going to be the segment connecting the two bases. So it's connecting the two bases and perpendicular to those bases. So like the segments BA, for example. So up here from B to A, that is one altitude. It's connecting the two bases. Or you could have CF. So from C to F, that's also connecting the two bases. It's perpendicular. DE is another altitude. Any of those would be altitudes. And the height is the length of that. So they're kind of used interchangeably, height and altitude. But the length of the altitude would be the height. So BA, CF, or ED, the length of those segments would be the height. And then the lateral face would be the sides that are not the bases. So the bases were the triangle part. The lateral faces are the other sides, so the rectangles in this case. So you have rectangle BAED. That'd be, this rectangle on the right side. So that'd be one rectangle. Then you have DEFC. That'd be on the bottom. So DEFC. It's rectangle on the bottom. And then you have this left side over here, BAFC, is another rectangle. So those sides that are not the bases would be called the lateral faces. Now those terms are important because we need to understand those as we develop our formulas for finding what's called the lateral area and also the total area of prisms. So what is the lateral area? Well, lateral area is the area of the lateral faces. And that's why it's important to know the terms, because lateral faces would be the sides that are not the bases. So for rectangular prism would be like the left and the right side, and the front and the back all put together. So not including the top and the bottom. So we're trying to find the area of all those faces put together. So we could do this two different ways. We could either A, find the area of each of those rectangular faces and then add together. So we do like the front area, so take the area of that rectangle, add that with the area of the back, add that with the area of the right side, and then with the left side. And put those all together, that gives you the lateral area. Or there's a shortcut way we can do this. And the way to do this is we basically do all rectangles at one time. And the formula is right here, and I'll explain where it comes from. So lateral area is perimeter of the base, so P, perimeter of the base, times height, so the height of the prism. So where does it come from? Well, if you think of each of those rectangles that we had, so the front, the back, the left, the right, they all had the same height, right? Each of those rectangles had the same height. So we basically do the rectangle formula of base times height, but instead of doing each rectangle separately, we combine all the bases together. So if we take the base of this rectangle in the front, and then take the base of this rectangle on the right side, and then the base of the rectangle in the back, and the base of the rectangle on the left side, put those all together, and that gives you the perimeter of the base, the distance all the way around. So that's where it comes from. So we take the perimeter of the base times the height, because we're doing all the rectangles at one time, putting all those bases together, and the heights are all the same for each of them. So we just have P times H. All right, so what does this look like? Well, let's try an example where we are given the lengths of 10, 6, and 4 inches, and we're told to find the lateral area. So again, the formula is perimeter of the base times the height, and the height is the height of the prism. And so what is the base? Well, the base is this rectangle down here, right? This rectangle in the bottom. That is one of your bases. We also have one on the top, but we just take one of them, one perimeter. So what's the perimeter of this rectangle? Well, we have 10 by 6 by 10 by 6. So you can add those all together. So we have 2 10s, and then we have 2 6s. So 2 10s is 20, 2 6s is 12. 20 plus 12 is 32. All right, so the perimeter of the base is 32. And then the height of the prism, that's going to be 4. That is the distance from base to base. So H is 4, perimeter is 32. Multiply those together. 32 times 4 is 128. So the area of all the lateral faces put together is 128 square inches. So notice that is much quicker than trying to find the area of all 4 rectangles and then add those all together separately. All right, and then we also have what's called the total area, or surface area. So the total surface area of this rectangular prism would be the areas of every part. So not just the sides, but also the 2 bases, the top and the bottom. So to find the total area, we take the lateral area, then just add in the area of the 2 bases. So that's your formula. Take the lateral area, add in the 2 bases. So the 2 bases we have here in the bottom is our base. We have one on the bottom and on the top. So the area of that, the base, would be 10 times 6, base times height, which would be 60. All right, so you have 60, and you have 2 of those. So you take the lateral area of 128 plus 2 bases, so 2 times 60. So that gives you 120 that you add to the 128. So we take the lateral area, add in the area of 2 bases put together, and that gives you a total area of 248, and it's going to be square inches. That's your total area of all the rectangles, of all the surfaces of this rectangular prism. So we have found the lateral area and total area of a rectangular prism. Now what about a triangular prism? Well, again, it's going to be the same basic formula. So the lateral area is the area of the lateral faces. So the lateral faces are the sides that are not the bases. So the bases are the triangles. So the lateral faces are these rectangles. So we could go the long way and find the area of each of these rectangles and then add them all together. But we can use the shortcut, which says we can do the perimeter of the base times the height. Well, the base, make sure you get the base correct, because that's going to throw off your answer if you don't know the different parts of this prism. But the base is the triangle. So we have 2 bases, 2 triangles. And the perimeter of the base would be the distance around that triangle. So you add those side lengths together, 4.5 plus 4.5, that gives you 9. The 9 plus 6 gives you 15. So the perimeter of the base is 15. So that's the perimeter of the base is 15, and then the height is the height of the prism. So not this 3.35 inches over here, but the height of the prism, which is this segment connecting the 2 bases. Well, you have one there, you have one on the top as well. That segment, the length of that height of the prism is 10. So we have 15 times 10, which is 150, and the units are inches. So we have 150 square inches. And that's your lateral area. That's the area of these 3 rectangles, the one on the right, the left, and the bottom put together. So we have the lateral area, and then we can also find the total surface area. So the area of all the surfaces put together. So this would include not only the lateral area, but also the area of the 2 bases. So what is the area of the 2 bases, or the 2 triangles? So here's your your base, here's another one back here. We have two of them. All right, so it's a triangle, right? So what's the area of a triangle? Well, it's 1/2 times base times height. So make sure you are multiplying the correct things here. This is lowercase b. This is the base of the triangle. And the height is the height of the triangle. So back here, notice the height of the triangle is 3.35. It's the same as up here. So this is 3.35 as well. So that's your height, and the base is perpendicular to that. So the base would be the 6, the base of the triangle, and the height of the triangle is 3.35. So we have 1/2 times 6 times 3.35. So 1/2 of 6 is 3. 3 times 3.35 gives you 15, carry the 1. 10, carry the 1, that's 10.05. So that's the area of just one of the bases. We have two of them. So we have 150 for the lateral area plus two bases. So 2 times 10.05. Well, what is 2 times 10.05? That's going to be 20.10 or 20.1. Add that with 150. That gives you 170.1. And it's going to be inches squared. So the area, the total area of all the surfaces of this triangular prism would be 170.1 square inches. And we can also call that the surface area. That is the total surface area, or the area of all the surfaces of this triangular prism. Now to finish off, we have a special type of rectangular prism called a cube. And this is a specific type of prism where all the edges are the same length. So this would be like a die or dice for a game, maybe like Yahtzee or something. So a cube would be something like that. All right, and this one's a little bit different. I mean, you can use the same formulas, perimeter of the base times height for lateral area. You can use the, lateral area plus the area of the two bases for the total area. But since every face is going to be the same size, they're all squares, we can actually use a shortcut. So the lateral area, remember, is the area of the lateral faces, which would be, like this front here, the right side, the back side here, and then the left side. So it's everything except for the top and the bottom. So what we have is 4 squares, or 4 different faces. All right, so what is the area of one of the faces? Well, if it's 3 by 3 square, 3 by 3, the area is base times height, or 9. So each face is 9 inches squared. So if there's 4 faces, 4 lateral faces on the sides, we just do 4 times 9. 4 times 9 would give you 36. So 4 times 9 is 36 inches squared. That's going to be your lateral area. So your lateral area is 36 inches squared. And then your total area would be the area of all the different faces. So not just the lateral faces, but also the top and the bottom, the two bases. So there are 6 sides of the entire thing for all the surfaces. So we have 6 faces for total area. Multiply that by 9, because the area of each face is 9. That gives you 54 inches squared. All right, so the total area, so the total surface area of all the surfaces put together would be 54 inches squared. So in this lesson, we have learned different terms and different parts of both rectangular and triangular prisms. We also learned how to find the lateral area and the total surface area of each of those shapes. And that concludes our lesson for today. We will see you next time.